Hi everyone, welcome back to my channel. This is Vamsi Reddy. Today we are going to discuss about one of the new topic on qualitative aptitude. In this aptitude topic, I am going to discuss about the numbers. This is a one type of chapter, or you can think like this is a one type of problem. We have a number of problems on based on clarifying on numbers. So let's move into the deep. You can know about this thing. Okay. At first, we want to see that operations on numbers. At first, what is mean by the number? In Hindu Arabic system, we have a 10 digits which starts from 0 to 9, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up to 9, this is a Hindu Arabic. Based on these 10 digits, we can create the whole numbers. We can design the number of things using these 9 numbers, like millions of trillions of the numbers we are generating or creating by using these 10 digit numbers. Okay, let's move into that operations on numbers. At first, we can see that natural numbers which we easily count, the number which can starts from 1 to infinite, it is known as natural number, like 1, 2, 3, 4 and so on up to infinite, but it is denoted by the n, capital N, and 0 does not include in these natural numbers. Whereas the next one is whole numbers. Whole numbers is starts from 0 to infinite. It means it can start from 0. It includes the 0 at the starting of the numbers, natural numbers, starting of the natural numbers. Okay, that set of numbers is called whole numbers. It is represented with capital W, and the third one is integers. We know that integers is the whole numbers included negative and positive numbers, like minus infinite to 0 and plus infinite, including minus and infinite and plus infinite. Between we have found a 0, it is integers. And prime numbers, the number which can be divisible by 1 or itself is known as a prime number. We can consider say that the number which is divisible by 1 or itself, it is known as prime numbers, like 2, 3, 5, 7, 11, 13, 17, 19. These are the prime numbers that can divisible by itself only. By using another numbers, it can't be divisible. Okay, next one is co-primes. Two natural numbers p and q are said to be co-primes if their HCF is G1. If two numbers A or B numbers whose HCF is 1, then we can say that they are the co-primes, like 2, 3, 4, 5, 7, 9, 11, 9. These are the co-primes numbers. Okay, and next one is composite numbers. Composite numbers, it refers to the whole number which is greater than 1 and is not a prime number, which can be divisible greater than 1 or any itself or anything. Like if you consider an example of 40, it is a co-prime because it can divisible by itself and with 2, 3, 4 and 10 also. So more than 1 or itself, it is that those numbers are considered as a co-primes. Okay, and the next one is even numbers. Simply we can say that an integer which is divisible by 2 is known as even numbers, like 2, 3, 4, like 2, 4, 6, 8. These are the even numbers. Whereas odd numbers, the integers which is not divisible by 2, like 1, 3, 5, 7, 9. These are the numbers which can't be divisible by the odd numbers. Next ninth step is conjugative numbers. It is a series of numbers in which the numbers follows by each other in an order. There is a difference between 1. The difference of 1 between the two successive numbers or each number is greater than other predict. It means that in a series of numbers there is a difference between two successive numbers, between the difference is 1. This type of numbers is called conjugative numbers. And the 10th one is national numbers. National numbers is a very important thing. We have also learned in our 9th and 10th standard also. Natural and the number in the form of p by q. It is in the form of p by q, like division format or form of p by q, where p and q are integers. You can say that p and q are integers, where q is not equals to 0 because denominator does not equals to 0. So this type of numbers is called irrational numbers or rational numbers. Rational numbers. Whereas irrational numbers is one type also. The numbers which even write in the decimal form do not terminate and repeat as known as irrational number. This can be expressed in the rational. So it is in the form of fractional numbers. The numbers which can written in the decimal form. We can write in decimal, but we can't terminate that. the type of numbers is called irrational numbers. Like example, root 2, root 3, root 5, pi, etc. These are the numbers are irrational numbers. And finally, last one is real numbers. The number which can be found on the number line and including both rational and irrational number is known as real numbers. We can say that irrational and rational numbers are known as real number. Both we are combined, like minus 1.1, root 2, 0.12 pi. These are the numbers are real numbers. Okay, let's move into another one. And this is the main thing you can focus on from now. What is the main difference between the face value and the place value? Whereas a face value indicate it is the actual value of a digit, it remains defined and does not change its place. It means face value means it can be simply say which type of number is. Whereas a place value, the position of number, it can shows that. If for example, if you take 567, where the 6th place is 10th place, 6 is located in the 10th place, so 6 into 10 we can know that 60. So that's why we can pronounce like 567. It means 567 where 5 is lies in the hundreds place and 6 is lies in tens place and 7 is lies in ones place or unit place. We can consider like this. And the final one is unit digit. Unit digit is the ones place digit or one of them. It means the number which is placed in the units place is known as the unit digit. Okay, these are all the overall about the operations on the numbers. Let's move into the divisibilities. Let's move into the divisibility rules. We have approximately 5 to 7 divisibility rules. By using these divisibility rules, we can solve every problem. Let's start with divisibility rule 2. Divisibility rule 2 tells us a number is divisible by 2 if it is unit digit. It means the number which can be divisible by 2, it will place in unit place as 0, 2, 4, 6, 8. These are the numbers are divisible by 2. For example, here 5, 8, 6, 4 is a divisible by 2, yes, 2 or not. Yes, absolutely it will divisible by 2 because where we have a unit place, here the unit place is 4, it can be divisible by 2. Yes, it's 2. 2 ones are 2 2. It is divisible by 2. So that then the given number is absolutely divisible by 2. Next, divisibility rule 3. A number is divisible by 3 if sum of all the digits is completely divisible by 3. For example, it means sum of all the numbers in a given set is divisible by 3, then absolutely the number is divisible by 3. So here the 5864, we can sum that 5864 is divisible by 3 or not. We can find like that. So 10, 18, 18 plus 3. 18 plus 23. 23 is divisible by 3. If it is divisible by 3, we can say that divisible 3. If it does not, we can say that it does not. Okay. Next divisibility rule is divisibility rule 4. A number is divisible by the 4 if the number formed using the last 2 digits. It means if a given number last 2 digits is divisible by 4, then the whole the number is divisible by 4. Like for example, 87754, whereas the 24 is divisible by the 4, then the whole number can be divisible by the 4. Next rule, divisibility rule 5. A number is divisible by 5 if the units place. It means if the units place contains 0 or 5, it absolutely divisible by the 5. So for example, here the example 1 is 458620, where the units place 0, and the below example example 2 have 5. So both numbers are divisible by the 5. And the next divisibility rule is 6. Divisibility rule 6. If a given number is divisible by 2 and 3, it is possible to divisible by the 6. So that's we can say if a given number, if any number has given that number divisible by 2 and 3, then it is known as divisibility rule 6. Like example 6 to 1, whereas the units place is 2, it's absolutely divisible by 2. We can sum up all the numbers. It's 6, 3, 9, 10, 13, 15. 15 is divisible by 3. Exactly, this whole number is divisible by 6. It is if these two cases are work properly, then automatically divisibility rule 6 is executed. And divisibility rule 8, as we compare with the 4, where the last 2 digits on the divisibility 4, we have a last 2 digits are divisible by 4, then the whole number is divisible by 4. Like that only here the divisibility rule 8 says that last 3 digits is divisible by 8, then whole the number is divisible by 8. It's a simple remember thing for 4 and 8. We can see like this. And finally divisibility 9. It is a divisibility of 9. A number is divisible by 9 if the sum of the digits is completely divisible by 9. So we can sum, if a given number is whose number, we can sum all the number, and if it is possible to divisible 9, so the number is given to divisibility 9. And divisibility rule 10, and it's like that. It is similar to the divisibility rule 5, where divisibility rule 5 units place contains 0 and 5, but whereas in divisibility rule 10 it contains only 0. If unit place contains 0, it is absolutely divisible by the 10. And the last one of divisibility rules is divisibility rule 11. Divisibility rule 7 means where the sum of even digits and sum of odd digits is divisible by 11, then the our given number is divisible by 11. Like for example, we have 5773, where the sum of even places is 7 and 3, so 7 plus 3 is 10, and sum of odd places 5 plus 7, so 12, plus 10 plus 12 22, 11 to the 22, it is absolutely divisible by the 11. So this type of problems we can clarify like this. And these are the some basics formulas you want to remember, and in this solving of the numbers based problems, like a plus b whole square is equals to a square plus b square plus 2ab, a minus b whole square is equals to a square plus b square minus 2ab, a plus b whole square minus a minus b whole square is equals to 4a, a plus b whole square plus a minus b whole square is equals to 2 into a square plus b square, a square minus b square is equals to a plus b, a minus b. Like these are the some of the basic formulas you want to remember to solve the basics numbers. So this is overall about the numbers. You have learned what are the operations on numbers, divisibility rules, and basic formulas. And this is a thing I want to show in this video about the numbers. If you like this video, please like and subscribe to my YouTube channel for more updates about anything like data science and web development and competitive programming and interview preparation. We are providing the best things. Okay, bye, take care.